Lesson 2.1 is linear and quadratic functions and modeling. Some of this is going to be review, stuff you've seen, stuff you know. Some of it's going to be taking it a little bit farther. Just kind of depends. So a little bit of review and vocabulary and whatnot. Polynomial functions. We talked about polynomials last year in Algebra 2. It was a little bit later in the year than this, although ironically enough, I'm teaching polynomial functions in Algebra 2 today, I just realized. So polynomial functions. Any function that is a sum or difference of x values that have whole number powers and real number coefficients. So we talk about polynomials, okay? Sum or difference of x values. So that's just x, terms added and subtracted. So when we talk about polynomials, we've got terms added and subtracted. Specifically, though, these terms must have whole number powers and real number coefficients. So we're not talking about any imaginary values. What do I mean by whole number powers? What are whole numbers?
Numbers that don't have decimals.
Numbers that don't have decimals and?
Fraction.
No decimals, no fractions, no negatives. So whole numbers, as a review, zero, 1, 2, 3, so on and so forth. Okay, just as a review, that's important to remember. Okay, polynomials have special names depending on their highest degree, their highest power. If I'm going to start down here at the bottom, just because I think it makes sense, if we talk about a cubic function, you guys know what a cubic function is. Cubic function has the highest power of 3. So right there, something where the highest power is 3, ax cubed, for example, that is a cubic function. Now, the degree there, your degree is your highest power, so degree 3, and leading coefficient. What is the coefficient in front of that highest power? So if my highest power is x to the third, what's the number in front of x to the third? And in this case, that is represented by a. Okay, so we talked about this last year. Quadratic. If something's a quadratic function, the highest power is a power of 2, right? That's quadratic. Highest power of 2, degree 2, leading coefficient, still a. Linear. What do we know about linear functions? Okay, y equals mx plus b is what comes to mind, right? And notice that is x to what power? X to the first, right? So it's a linear function. X to the first is the highest power, leading coefficient a. A constant function is when it's just a number. There's no x's. So a constant function is just f of x equals a. Now, keep in mind, what invisible power is there? This is a. This could also be written as a times x to the 0. Okay, because what is anything raised to the power of 0? 1, right? Good old exponent rule there. Anything raised to the power of 0 is 1. So the x to the 0 can drop out, just be a 1. And so that's our constant function. Degree 0, leading coefficient is still a. We don't talk very much about something called the zero function. Zero function specifically, instead of equaling some number, just equals 0. Okay. Officially, it's undefined with your degree. Leading coefficient is 0 because that's the only number there. Okay, so a little bit of vocabulary, whatnot there. One thing we're going to talk about is which of these are polynomials, which of these are not polynomials. So which of these fall into the category of sum or difference of x values with whole number powers and real number coefficients. So example A, f of x equals 4x cubed minus 5x minus 1/2. We need to figure out if it's a polynomial. If it is, I'm going to ask you, we're going to talk about what is the degree and the leading coefficient. If it's not, we need to talk about why is it not a polynomial. So thoughts on A? Polynomial or not a polynomial? Does it meet these requirements up here? Sum or difference of x values. So they're basically terms added and subtracted together. Do these terms have whole number powers and real number coefficients?
Yeah, first I'd say it's
Okay. So when we ask the question, is it a polynomial? Yes, it is a polynomial. Okay. It is a polynomial. What would be the degree?
cubic.
Okay. 3 or cubic, depending on what they're looking for. It's a degree 3 or cubic because that's the highest power, yes? Okay. So either 3 or cubic. I honestly can't remember what this answer key has. And leading coefficient. I'm going to abbreviate LC if you don't mind. What is my leading coefficient? 4. Because that is the coefficient or the number in front of that x cubed term, the highest power. Okay, what about B? G of x equals 6x to the negative 4th plus 7. I can't even finish reading it. Why are you guys telling me no right off the bat?
Negative exponent.
X is to the negative 4.
Okay. Right there, guys. That is a negative 4. And polynomials, every term in a polynomial must have whole number powers. Is a negative a whole number power? No.
Yeah.
And another way to think about this is this would end up being 6 over x to the 4th. And we can't have x's in the denominator of a polynomial. Okay? So, is this a polynomial? And I'm going to say no. And our reasoning is that not whole number powers. So, power is not a whole number. Or in other words, the negative is the problem. Okay, C. H of x is the square root of 9x to the 4th plus 16x squared. Is it a polynomial?
I think so.
Practically, yes.
You simplify it.
Yes. You have to square both sides.
Well, this is a function, h of x equals, so I can't square both sides to get rid of the square root.
It's been long.
That's
Okay.
H squared.
What is a square root as a power?
2.
Whatever's on the inside.
What's that first?
Just
Are you?
Square root. If I was going to take this square root, or this radical, and instead of writing it as a square root symbol, write it as a power. Yeah. You remember, if this is a square root, the index is 2. That little number in the radical is a 2. And so that is your denominator of your exponent. So this is 9x to the 4th plus 16x squared, all raised to the power of 1/2.
So no.
So I'm leading you to say that this is
I said
not a polynomial because of 1/2 is not a whole number. Okay? And no, I cannot just say, oh, I'm just going to now take the square root of 9x to the 4th and the square root of 16x squared. If this was just one term, yes, we could take the square root of the whole thing and we might be able to come up with a different response. But since these are multiple terms added together, you can't, it's not legal to distribute the 1/2, so to speak, which I know is what you guys want to think there. So, this again is not a polynomial, and this time, well, same thing. The power is not a whole number, except this time it's a fraction or a square root. So power is not a whole number. And as I said, this time the issue is the square root. Okay? And D. K of x equals 15x minus 2x to the fourth. Is it a polynomial or not?
I feel like it's supposed to be yes.
Yes.
But it doesn't look like
I think it
one.
is. Yes.
But it's
What?
negative 2.
But it has the coefficient is a real number.
Interesting.
If you
What?
put it in-
Exactly.
Isn't it because it's, you can
Oh.
just
If you
flip
put
it
it in
around
order,
and say
it'd be
negative
negative
2x
This is quite the
to
predicament.
the 4.
Unless you
But
just
there's
2x
no-
to the 4th minus 15.
There's no rule that says it can't be negative 2x.
Yeah, I realized that.
Yeah, it's
Well, why don't you just flip it?
Okay. Could we rewrite it like
You
that?
just did.
No.
She literally just flipped it.
Never mind.
Okay.
Keeps-
I heard the suggestion out there.
First question.
Is this equivalent?
Yeah.
That's still the same function written there, isn't it?
Me personally.
Okay. Is this a polynomial?
Yes.
Yes, it is. And here's, the key is it's sum or difference of x values. You guys weren't hung up on that, I don't think. Whole number powers. So the powers have to be positive whole numbers. Are my powers positive whole numbers? Yeah. And my coefficients just have to be real numbers. So can coefficients be negative? Yes, a real number can be negative. A real number basically means anything except imaginary. Okay. So, what did I have to state? The degree and the leading coefficient. So, what is the degree? Okay. Degree is 4, even though that wasn't my first term, yes? I rewrote it so it is now, but degree is 4 because that is the highest power. What is my leading coefficient?
Negative 2.
-2. So the coefficient of that highest power there. Okay, got that all straightened out? Okay, important to have an idea of what a polynomial is, what, pieces do and don't fall into the rules there. Okay, moving down then. Linear functions. We're going to focus a little bit on linear functions here. The wording vocabulary may look a little different, but you know how to do everything we're getting ready to do. So linear function, a polynomial of degree 1 with a leading coefficient equal to the slope. We talked linear functions earlier. Connor mentioned y equals mx plus b, yes?
Yeah.
Right there, guys. Ax plus b, mx plus b. Same idea. So degree 1, and that leading coefficient is your slope. Now, the constant function is the graph of a horizontal line, and vertical lines are not functions because they do not pass the horizontal line test. This should say, I knew there's a typo in here somewhere, vertical line test. Okay, so linears are what we're focusing on right now. Constant is the graph of a horizontal line, so that's still linear. Vertical lines are not functions, though, because they do not pass the vertical line test. So, thus, anytime we're talking about linear functions, they are the slant lines, okay? So they're the lines that have the positive or negative slopes, not the zero slopes. So let's look at example 2 here. Write an equation for the linear function f of x such that f of negative 1 equals 2 and f of 3 equals negative 2. Well, what does your brain say when it says write an equation for the linear function?
Y equals mx plus b.
Okay. So right here, your brain needs to connect, equation of linear function. She wants us to write y equals mx plus b. Slope-intercept form. Not the only form you can write, but that's the form that our brains know the best, right? Such that f of negative 1 equals 2 and f of 3 equals negative 2. What are they giving me here?
Y values.
They're giving you numbers to plug in.
They're giving you numbers to plug in that this is an x and a
What?
y.
Oh, so what is?
So then you have to find.
So they're
Oh.
giving us an ordered pair, -1, 2, and they're giving me an ordered pair, 3, -2. Okay, that's common. Like how kids see it that a lot, in that instead of giving it to you in an ordered pair form and making it obvious, they're going to give it to you a function. They're going to say, okay, when I plug -1 into the function, I get 2 out. Well, you have to interpret that, oh, that's the ordered pair, -1, 2. Okay, so what are we going to do then?
Plug in the point.
Slope. Okay,
Slow.
so if we're using -1, 2, and 3, -2, okay, how do I find slope?
Y2 minus Y1
Y2 minus Y1 over X2 minus X1. That rings some bells, right? Let's see. I'm guessing you guys are going to say -2 minus 2 over 3 minus -1. -4 over +4. So what do we know?
Slope is negative.
Slope is -1. Now what?
Find y-intercept.
You can use either way.
How do we want to find the y-intercept?
Take the -1 and the 2 and plug it into the x1 and the 1 from the negative.
Okay. And what equation are you putting these into?
The y.
Okay, so I have 2 routes here to take you. And I'm going to go with the direction you guys lead me, which is perfectly fine. Which point did you tell me to use?
-1, 2.
Kylie said -1, 2. Officially, doesn't matter which ordered pair you pick. No. So if we use those 2 pieces right there, and if we use the form y equals mx plus b. Okay, so that means y is 2, slope is -1 times the x value of -1 plus b. -1 times -1 is 1. So if 2 equals 1 plus b, subtract 1, and b is 1. There's a lot of 1s in this problem. And so you can write the equation y equals -1x plus 1. Except I wrote -x plus 1 because do I really need that extra 1 there? Okay. So I did that with the idea. We found slope to be -1. We found y-intercept to be +1. Now, I know I taught this in Algebra 2 last year for those of you that had Algebra 2 with me. And I'm not saying you have to use this. However, could we use point slope to get there?
Yeah.
Do you remember point slope?
Yes.
I may have even gone over it this year. I don't know.
Yeah.
You did.
Okay. And you know what? I think I could actually fit that. I'm going to move this. Y minus y1 equals m times x minus x1. You could do it the same way. You could do this problem using this form and get to the same answer, right? So we could have also instead said y minus, what was our y? 2 equals slope of -1 times x minus, what is our x value? -1. And so then it would be y minus 2. Distribute -1, so -x. -1 times +1 would be -1. And then you could add 2 over y equals -x plus 1. Okay. I don't care which way you go, right? I will say the farther you go in math, there's definite value to using this. Okay. In calc, a lot of times we'll leave answers more in this form as opposed to going to the slope-intercept form. So being familiar with both is good. What could y be replaced with here, depending on what the request was of the problem? Right. We could also write this as f of x equals negative x plus 1. And you understand that is equivalent, right? So, okay, questions there?
So I'm not remember which one you was used, point slope or...
Which method to get to your answer?
Yeah.
Whichever one you want.
Okay.
I don't have a definite, on something like this, when that's my final goal is to get the equation, I don't have a definite. There might be times I will in the future, but either or.
Will there be, like, will they specify what form they want it in? Like, fx or y?
Oh, in terms of using y or f of x?
Yeah.
I don't know.
Okay.
Now, I will say, technically here, should we have known that they wanted f of x?
Yeah.
Technically here it says, doesn't it? Write an equation for the linear function f of x. I honestly can't remember. I looked at homework over, no, actually it was last week of school. I did the lesson plans for this week. So I haven't really looked at pre-calc since then to remember what was in there, but
Still the same, basically.
yeah, exactly. And I'm not usually too picky about whether you use f of x or y. So, okay, top of the next page, we're going to talk about average rate of change. And average rate of change, to me, it's a fancy way for saying slope. Okay. The slope of a linear function, m equals y2 minus y1 over x2 minus x1, characterizes something called the function's rate of change. Okay. All linear functions' rate of change, the m, is constant. So it's as you follow a slope or a curve, okay? At what rate is that curve changing? With a linear function, it's always the same, okay? All functions have rates of change based on different values of x. There's an average rate of change for a function, however, given an interval. So, for instance, if you look at a parabola, that's not going to have the same slope everywhere you look, okay? But what we can do is, on a given interval, you can find an average rate of change. So kind of an average slope in a way. We don't call it the slope at that point, though. It's average rate of change. So keep in mind here as we talk about rate of change, and keep in mind basically your slope formula, because that's going to look familiar as we look at what we're doing on the top of the next page. So average rate of change of a function, y equals f of x, between x equals a to x equals b. So those are the end points of my interval, where a cannot equal b, because if a and b are the same number, that interval is non-existent. Can be, and a to, when we talk about an interval a to b, you'll often see it written in interval notation as a to b. Okay, so average rate of change, we're going to use this formula right here. Basically slope, guys. F of b minus f of a over b minus a, where b and a are your x values, and then f of b and f of a are going to be your y values. So thus I'm saying basically slope. But this is average rate of change over the interval a to b. So let's look at example A here. Compute the average rate of change for f of x equals x squared from x equals negative 2 to x equals 0. So what are my a and b values?
Negative 2 and 0.
We're going to think of a being our negative 2, and we're going to think of b being 0. Okay. Nothing officially says a has to be smaller than b, but when we write interval notation, don't we usually write smaller number to largest number? And so thus, a is traditionally smaller than b. And so first thing I'm going to do is I'm going to think about finding f of a and f of b. So I'm going to find f of negative 2, and f of 0. How do I find f of negative 2?
Plug it in.
Okay, plug it in, right? F of x says x squared, so f of negative 2 says I'm doing negative 2 squared, which is 4. F of 0.
Pardon the interruption. Sissy East, please come to the middle school office. Sissy East, come to the middle school office, please.
Okay, so f of negative 2 is 4. F of 0 is 0. I went ahead and did that one without you guys. Hope you don't mind. I figure as much. Okay, so there is our information that we're going to have to use. Now, as we set up average rate of change, folks, f of b minus f of a. So in that case, this means we're going to be doing f of, what was our b? F of 0 minus f of negative 2 over b minus a. So 0 minus negative 2. And I won't always go through all this setup every time. What is f of 0? 0.
Sorry, 0.
Minus f of negative 2 is 4. So 0 minus 4 over 0 minus negative 2. Do the math. Should get negative 4 over 2, which is
Negative 2.
negative 2. So average rate of change on the interval from negative 2 to 0 is going to be negative 2. Now, think about it, guys. What is f of x equals x squared? That's a parabola, yes? And when we're on the interval from negative 2 to 0, we are right in there somewhere, aren't we?
Yeah.
Does it make sense that the slope of that area averages to be negative 2? Okay. Okay. Let's try b. F of x is given as 3x squared minus 1. X is negative 5 to x is 3. So we have our a and our b value, correct? What do we also probably need to find? F of negative 5 and f of 3. So if we're finding f of negative 5, 3 times negative 5 squared minus 1. What do you guys get?
I got 74.36.
Yeah, 25 times 3, 75 minus 1 is 74. Then we put in 3. 3 times 3 squared minus 1. 9 times 3, 27, minus 1, 26. Okay. Set up your f of b minus f of a. So in this case, I'm going to set up 26 minus 74 over 3 minus negative 5. Is that negative 48 over 8, which is negative 6. Okay. Now, officially, is this like slope where we could also do this exactly the opposite and still get the same answer?
Yeah.
Could you have reversed and said 74 minus 26 over negative 5 minus 3 and gotten the same answer? You can. Okay, average rate of change works like that, just like slope. Okay, we can go ahead and set up C. However, there's a little catch on C we need to talk about, and I know I don't have time for that today. So go ahead and start setting up C, and we'll talk about the simplifying part tomorrow. What What, you don't like this one?
How do you even
No,
set it
no,
up?
darn
There's no
it.
other numbers.
Is
Okay.
A from the is like the top A.
So it's saying from A to C. So think of this as this is going to sound weird, but as your A and your B, right? So like last time we plugged in -5 and 3. What am I plugging in this time?
A and C.
A and C.
So this is all going to be in like terms of equation.
Yeah, your answer is going to be in terms of A and C
God.
here. You're not going to have a final number answer. Okay. So, yeah, fun stuff, right?
Sometimes they just having like these problems where we're just finding the equations, and so then it's like you're trying to find out the final like completely simplified equation. It's like the worst thing ever.
Physics.
Yeah.
It's a little, Okay, we will work on C tomorrow because we'll need time to simplify that. Homework, you can start looking at it. Now, I will say that homework that's listed up there goes with the front of the page of the notes and the back of the page of the notes. So once we get through linear correlation, that homework will be ready to go. So we'll finish the notes for that tomorrow, and then
So it'll be due on Wednesday.
it'll be due on Wednesday, yeah. I may or may not, there's a separate assignment to go with the quadratic function part.
We'll have to do it.
So.
We don't have to do it like right now. You can do it.